All right, 51. Again, we are finding the requested value, and we have to find f of negative 7 for the function f of x equals 5x plus 1 if x is less than 7. We have f of x equals 7x if 7 is less than or equal to x, less than or equal to 12. And lastly, we have f of x equals 7 minus 9x if x is greater than 12. All right, so let's see where this negative 7 falls within our domain restrictions so that we can determine which piece of this function we're going to use to evaluate. All right, so let's see. Let's start at the bottom. I think we've been starting at the top, so we'll work our way up, starting here at this last piece. So we have f of x equals 7 minus 9x if x is greater than 12. So let's see. Negative 7 is greater than 12. Is that a true statement? Is negative 7 greater than 12? No, that's not true, right? So we can go ahead and eliminate this last piece here. How about f of x equals 7x if 7 is less than or equal to x, less than or equal to 12? Well, let's see. 7 less than or equal to x. Well, in this case, x is negative 7. Less than or equal to 12. How about this? Is this a true statement? Nope. Again, not true. This is false. So we can eliminate this second piece here. Well, that only leaves us one piece left. Hopefully our domain restriction will apply. Let's see. F of x equals 5x plus 1 if x is less than 7. So we have negative 7 is less than positive 7. Is this true? Yep, sure is. So we know then that this will be the piece of the piecewise function that we'll be using to evaluate for f of negative 7. So let's see. So we have f of negative 7 is equal to 5x plus 1. So 5x, and in this case our x is negative 7 plus 1. Well, this is, well, let's see, 5 times negative 7 is negative 35, and then plus 1, negative 35 plus positive 1, so plus 1 is negative 34, and there we have it, number 51. We found f of negative 7.